day, welcome back to my channel. This is me again, Engineer Johnski at your service. So this time I'll be discussing DC motor. The topic is torque and power developed in a DC motor. Okay, so torque is a measure of how much force is acting on a rotating object. So the gross torque is the torque developed by the armature. So the formula for the power is equal to the back EMF times the armature current, where you can also solve for the power by using this formula, 2 pi nt over 60. So n, where n is the speed and t is the torque. Okay, so combine the two formulas. Okay, so the torque developed in the armature is given by the equation, this one, T is equal to Pz flux times the armature current divided by 2 pi A. So asa manigikan ng mga formula. So deriving this formula, so wait a minute. So P is equal to P, so therefore, okay, so AB times IA which is equal to this one. Okay, so but AB is equal to Epson, no? Epson. So copy. Okay, so AB is this one. Copy. So substitute na to dire. Okay, so multiply. Okay, so as you can see, cancel out ang 60. Okay, so cancel out ang 60. So can copy. Okay, so cancel out ang 60. So wala lang ni. And then also n. And then so wala na, no? Okay, so to solve for torque, so this will become 2 pi nt na lang. So 2 pi nt, so therefore T okay, so this is the formula, so diwin ang sagikan. Okay, so T is equal to P Z flux times the armature current divided by 2 pi A. So where P is not a power, this is the number of poles, Z is the number of series conductors, and flux per pole times the armature current divided by 2 pi A, where A is the number of parallel paths. Okay, so MP for lap winding and 2M for wave winding. So after assembly, you cannot vary what is inside, no? So number of poles will become constant, number of series of conductors, and as well as the number of parallel paths, no? So you can't vary, kaya naman susunod. So that those variables will become constant, no, after assembly. So what will happen? The formula will become like this, no? So torque is equal to key is katonika na sila BZ over 2 pi A, no? So muna siya ang key. So what is left is the armature current times the flux. So when the same motor, DC motor is tested in different parameter, like for example different current rating and different flux per pole, so this will become the formula, no? So torque number 1, torque or the first parameter, torque for the second parameter, and so on and so forth, no? So shaft torque is the torque available for useful work. So it is so called shaft torque because it is available at the shaft of the motor. So the horsepower obtained using the shaft torque is what we call brake horsepower, or BHP. BHP. So power also, no? We're looking at here. So we can solve also for power by using this formula, no? Where power is in HP. So dire, ato unit dire is watts, no? Watts na siya. So dire kung HP na, so remember that conversion, 1 HP is equal to 746 watts. So multiply lang nimo ang 60 by 746, so muna na yung resulta 4470760. And N is RPM, and torque is Newton meter. So kung ato sa i-convert from Newton meter ang atong torque dire to pound feet, no? So 1.356 lang atong conversion. So muna na may tabo. So divide lang nato ang 44760 by 1.356. So muna siya ang resulta, no? So 33,000. Okay? So let's have an example. So the armature of a DC motor running at 1,200 RPM carries 45 amperes in current. If the back EMF is 130, what is the torque developed by the armature? So let's solve this one. So remember the formula for the power, no? For the power, okay. So remember, this is the formula for power, right? For power. So in watts. So the back EMF times the armature current. Okay, so by substituting, since we have armature current and we have the back EMF which is 130, so the power is equal to back EMF is 130 times 45 amperes, which is equal to, so 130 times 45, 5850. So P is equal to 5850. This is in watts, no? So na naman tayo power. Okay, so this is the power. Okay, so the question is asking, the problem is asking for what is the torque, no? Torque. So remember the formula in watts, no? So we have this formula 2 pi nt, right? So 2 pi n t over 60, no? So we're atong P diri is in watts and is RPM, the speed. So what is left is the T. Okay, so substitute the given as well as what we have solved the power. So we have 5850, and then N is 1200 RPM. So torque, so T is equal to, so solve na to. 2 pi minus 60 na siya. Then 2 pi times 1200 x. So 46.55. So 46.55. The unit is Newton meter. So this is the answer, no? So atong bantayan lang diri, no? Atong bantayan is the unit, no? And you should also vigilant of kanang identifying the given, no? So is armature current, back EMF, the speed. Okay, so that will be all on this video. Thank you and God bless everyone.